How's it going, everybody? Welcome to another live stream repair. We've got 3 HomePods that showed up today for various repairs. We'll start off with Sam's HomePod with death farts. Then we'll move on to Boisy's HomePod with no power. And then we'll wrap up with Edward's that also has no power. So give me just a sec here while I open Sam's HomePod up and we'll get started. There we go. So, Sam's HomePod here. Sam says that they've got death farts. So the reason why the death farts occur is because of a few DC filtering capacitors on the back of the amplifier that tend to go bad over time and allow more and more DC voltage through the amplifier before it gets to the subwoofer. And once that DC voltage reaches past around 2 to 3 volts, that's when the amplifier will trigger the death fart sound and a forced restart. Some of the symptoms that may be accompanied by the death fart behavior here, obviously since it's pumping so much DC voltage into the subwoofer, one thing that we can expect to hear, and that's what we'll go ahead and check, is for a very loud and noticeable popping sound after the HomePod wakes up the amplifier from any sort of low power mode. And then again, if the amplifier goes to low power standby mode. One of the quickest ways to reproduce that is to simply just plug it into power, wait for it to finish booting, and then we'll tap the top to trigger Siri, which will wake up the amplifier. We'll listen for how loud that pop sound is, and then we'll listen again when we unplug it from power, how loud that popping sound is. So let's plug it into power, and very good, so we do have power. Let's go ahead and crack open our beverage here. And listen for the pop.
I'm having
Yep, so that was a pretty noticeable popping sound. You can really tell that it was coming from the subwoofer speaker there, and it wasn't just a very quiet like popping or clicking sound. Very noticeable. And then if we listen again after we unplug it from power, again, pretty noticeable popping sound. We can feel it in the table pretty much here. So let's crack this open and do a little bit of diagnostics from the inside. We're going to start with our metal spudger and use that to cut through the adhesive on our first layer here. We're not using this spudger to pry this off. We're just going around a few times to cut that adhesive. If we use this to pry, we would risk scratching it or cracking it. So we're just going to work through that adhesive a few times around until this just wants to pop off pretty much all by itself. Just like that. And then we can break out our fancy brand new electric screwdriver, courtesy of Jim, with a long T6 Torx bit here. And we're just going to remove those screws. And we can pry this display out. I'm going to use our metal tool to get it started, and then our plastic tool to do the actual prying. Just like that. And then we'll go ahead and stick this adhesive back down. What's up, nerds? All of our audio settings are looking good on our end. Hey Tony, welcome to the chat. We just got started. Trying to stick this back down. There we go. Now let's get our frame out. Okay. Yeah, I saw that. I got a notification as soon as he uploaded that. Had quite a few HomePod repair inquiries too since then. It looks like he actually fixes them for other people too with his replies to some of the comments or anything to take from that. So it's always nice to see more people offering repairs on these. He actually sent me a donation too, saying thanks for the info. I couldn't have done this without it. So if you're watching, thank you very much. Really appreciate it. Soon here I'd like to upgrade my camera setup to something a little more, well, just a little better looking. Alright, everything is ready for us to pry. It's not giving up easily. Well, that's too bad. There we go. Reveal yourself. Unnecessary. God. Stupid glue. Why would they do this? Sometimes it just makes you want to throw the thing across the room. No, it won't fit. Alright, let's get the subwoofer out. Now our woofer could come out. Let's just do a quick check of that woofer here since we've got it apart. Voice coil looks alright. Feels alright and nice and smooth. And I don't smell anything wrong, so that subwoofer appears to be pretty happy and healthy. Let's get this next layer out. And then our power supply. And finally, our amplifier. I gotta say, so far with this electric screwdriver, it's making this job much easier. And with this extra long T6 Torx bit, I haven't had any issues accessing any of these screws in here. And it's got plenty of torque to take any of these out. We'll see how much fiddling it takes to put them back in the right way. But I'm pretty optimistic so far. Quite happy with this. So one of the owners of a HomePod that had sent theirs in for repair just a few days ago had gifted us this electric screwdriver kit. And I was just waiting for a couple of longer T6 bits to arrive to get to use it here on stream, but this is the Hoto model QWLSD001, and of course my favorite feature is that it's got USB-C charging, but it's also got a light on the front there, so it'll light up the darker areas, and it's got enough storage in here to put any of the bits that you want. So I took some of the bits that it came without and put in a T6 and a T5 bit. extra long ones that I got off Amazon so that I could reach these tinier screws in here without bumping into any of these capacitors or the microphone board here. So this was one of the 2 tools that he actually sent us. Let me grab the other one here. Here is the other one. So this is also made by Hodo, but it's a lot smaller. And I haven't used this one yet, but it's also got USB-C charging. Nice little guy. We might try this out on the next HomePod here. But yeah, Jim spoiled us with the fancy new electric Hodo screwdrivers. And so far, I'm having a great time with them. Comes in this great carrying case too that you can just stick it in, store your bits, close it all up, and you're good to go. I think I remember seeing that specific one on Amazon. So if you're curious, just hop on Amazon and look up Hodo electric screwdriver and you'll find it. Okay, back to our repairs here. Before we do any changes or any sort of repairs, we're going to go ahead and throw these parts together on the bench just to do a quick diagnosis here. Double check and make sure that they are in fact seeing too much DC offset, which is causing their death farts because of the failing capacitors on the back side of this amp. So we're just going to throw our test parts on here real fast, get it all powered up, connect to our multimeter here, and we will see what we've got, what we're dealing with. I'm going to go ahead and guess that we've got around 400 millivolts of DC offset on our cold boot, and it'll probably obviously quickly grow to around 600 or 700 millivolts in a matter of seconds. Alright, everything has got a nice connection. Let's get our logic board in here and let's power this up. Alright, so we're well past 200 millivolts. Let's jump up to the 2 volt DC scale on the meter. And we see about 360 millivolts and quickly growing. We want this number to really stay below 50 millivolts. Anything past that is what most people consider to be in the realm of necessary for repair. Once you start growing past around 200 to 300 millivolts, that's when you can start damaging components in the long run. And once you start growing past 2 to 3 volts, which I'm sure if we talked enough and let this sit around for enough, we'd see it grow well past that, the amplifier would force our death farts. So let's go ahead and do our repairs on this board here and see if we can't get this DC offset here under control. We'll go ahead and unplug our power. Listen to that speaker pop. Gnarly. We'll go ahead and tear these off. Flip our board around, and I'll bring you guys up close to see what we're dealing with. Alright. There's the culprit, or should I say culprits. We've got our 4 DC filtering capacitors here. They sit after the digital to audio converter, but before the actual amplifier for the subwoofer. So what happens is the amplifier board here gets the digital audio signal from your logic board. This chip converts that digital audio signal to an analog audio signal, but it's still pretty weak, especially for a subwoofer. So it passes through these circuits here until it gets to the bigger amplifier IC chip. And all this chip does is it amplifies anything it's given. So along this path, if there is DC voltage present in our AC audio signal before it's sent to our amplifier chip, it's going to get amplified and sent to our subwoofer. So that can cause problems with your amp chip right here. It can damage that. It can damage your subwoofer, of course. It's putting it under additional constant load, and that can kill your woofer over time. And unfortunately, there's no easy, great way to test these, at least with a standard capacitance test, because these will typically still show a normal capacitance when they aren't actually filtering as much DC as they should be here, especially when we're talking about millivolts. Now, with death farts, that those don't occur until you start seeing DC offset in the realm of 2 to 3 volts. But you got to remember the amplifier here is just amplifying whatever's being sent through here. So what may only be a few millivolts of DC being allowed through these capacitors gets amplified and then sent to the subwoofer. So that can easily multiply from what seems to be a negligible problem to a major problem. Let's go ahead and get these 4 filtering capacitors replaced with new high quality ones of the same spec, and then we will go ahead and also replace the 60 volt 5 amp Schottky barrier diode located right here. This part doesn't have anything to do with our DC offset or our death farts problem whatsoever. However, this is the component that tends to fail the most often in Apple HomePods and cause no power issues. So we're going to replace this diode regardless of what other issues it's come in for, just to hopefully prevent that from occurring on their HomePod after unrelated repairs. So let's zoom back into our bad boys there, get those pulled off and replaced with new ones. Hey Exotic, welcome to the chat. They were asking, can I make a video on how to repair a Z-Edge 27-inch monitor? I don't have one of those, and I've never honestly even heard of them before. But if somebody wanted to send one of those in to get fixed up, and provided I can find any information online on any of the issues that it is experiencing, we can most definitely do a repair on the channel here and perhaps shed some light for others on how to do it themselves. I would like to know exactly what the failure is and then do a little bit of research beforehand just to see if it's something I can even attempt, because I don't want to waste anyone's time or money here. But I'm always willing to give things a shot if people are willing to spend the time in sending it in. Let me take a crack at it for the first time. Wouldn't be my first time doing a repair on a monitor. I've replaced plenty of capacitors or power supplies in monitors in the past, but nothing really on channel yet. I would love to, though. Alright, so really quick, we're going to use some low melt solder here on the pads for this capacitor. I just like to use low melt solder for these caps so that we don't have to subject them to as much heat. Hopefully extends their lifespan a little bit there by not putting them through so much. Also makes it a little easier to get 4 of them on there. Okay. Let's put a little more flux on there. We can never have too much of that. And then we will put our new caps on. If you're curious on which parts that I'm using here, like for these capacitors or for the diode, or any of the parts that we replace in our repairs, I've got all that info up on my website at the top left corner of the video there. Head to nixfix.com, and then there's a common issues section that you can head down to. And it'll give you, if you find which issue it is that you're experiencing, there's potentially different causes, so be sure you read through all of them first. But find your issue, and then you'll find ways to diagnose that issue and repair it, along with any of the parts that we usually use here on the channel. Of course, you're welcome to go and find any other part that is the same spec, but that's just what we use here, and it consistently works well. There we go, not bad. We're gonna hit those with just a little more flux and heat just to make sure we've got a nice quality, solid connection to our board. There we go. Alright. Fresh set of filtering capacitors. Should get rid of our DC voltage being amplified and sent to the subwoofer, which will prevent those death farts from reoccurring. Let's go ahead and flip this around, and we will take care of that Schottky barrier diode that loves to fail and cause the common no power issue. After we replace this, then we can give this board a quick test. So Tony asked, what's the weirdest thing you've repaired? Oh boy. If we're talking like weirdest thing that we've seen doing repairs on HomePods, there's the YouTube short that I uploaded with the blown power supply capacitor that leaked everywhere and corroded basically everything. That was easily the gnarliest and most extensive damage I've ever seen inside of a HomePod. Outside of that, I can't really think of anything super weird that I've worked on. Definitely seen a lot of weird things fixing people's computers, but we won't talk about that. I'm sure I'll think of a good weird thing that I've worked on here. It'll pop into my head. the screen is black in the corner. Oh dang, like the LCD actually cracked. So you're just trying to replace the LCD itself. Or is it perhaps a backlight issue and one of the backlights have given up? Or maybe one of the drivers for the backlights. So if you want to send it in for repair, of course shoot me an email first so that we're both on the same page. But if you go to my website, nixfix.com, and then at the top click mail-in repair, I've got my mailing address and contact info there that you can reach out to me. Yeah, that would be best if you shot me an email with photos of showing what's going on there. Then we can do a little bit of research and see if we can guess whether we can even repair it before we have you ship it in. Saves everyone time and money. Okay. We've done our necessary repairs on this board. Let's just give it a few seconds to cool down. We'll power it on and see if we fixed our DC offset. I'm just admiring the joints on these capacitors we replaced here. Very nice. Alright, first up, power supply. And our logic cable. If you haven't been able to tell by now, not all of these parts are obviously from Sam's HomePod here. What we ended up doing was completely dismantling a HomePod for its parts. So we harvested its ribbon cable and also the power connector that routes from the outside of the shell to the power supply inside, so that when we need to do any bench testing here, instead of having to throw everything back together in the HomePod shell just to test, we can just take our power cable here and power everything up this way. Makes repairs and testing much easier. So if you're going to be fixing more than one or two HomePods, I would strongly suggest picking up one just for the parts to be able to test things like this easier. Alright, everything is ready to test. Let's go ahead and plug it into power and wake up the board and wait for that to finish booting up, and then we'll test for DC offset. Okay, board is booted. I heard the base prompt from Siri there. And we've only got less than 1 millivolt of DC offset. So that is an A+ repair there. We've got our DC voltage coming from the amplifier almost completely removed and well within spec again. I didn't hear any popping when I woke it up. and our base is still working. So let's go ahead, unplug this from power, take the test parts off, and we'll put this HomePod back together and do our final sanity checks. I heard that iOS 16.1, or should I just say in general, OS 16.1 was released today for original HomePods. I've been getting it downloaded to all of mine today. I'm still waiting for them all to push through and finish updating, so I haven't had a chance to try it out yet, but I have faith, and I just updated them all at once. So we'll see by tomorrow when things settle down how the new OS behaves. I'm really hoping that they've improved performance and reliability when you've got multiple HomePods. I also heard that they were going to be adding in like AirPlay speaker groups. I thought that was going to be in 16.1, but maybe I'm mistaken. But that'll make it so much easier to AirPlay to multiple speakers at once instead of sitting there tapping to connect to one, waiting for that, tapping the next one, waiting for it. You know, when you've got, upwards of a few dozen that you want to connect to at once, it can take a long time just to start playing music, just by the process of connecting to them all before you even start. I'm going to use the manual screwdriver to put the screws for the amp here back in. But we'll break out the electric one again for the rest of the screws here. Reconnect that ribbon cable down there to the amplifier. Make sure it's nice and level and lock it in. Drop our power supply in. Reconnect that internal connector and screw it down. Where did our electric go? I just had it. Oh. Alright, let's see how this goes. Cool. Oh, that's got some torque. Oh boy. Can we, is that the lowest setting? Oh, jeez. Oh! Oh. Oh, jeez. Alright. We're going to put that to the side for now and fix that little boo-boo. That's no big deal. It appears that even the lowest torque setting on this is just too much for the screws in here and they will break, so not sure I would suggest using that here. That's funny. If you send the monitor in, and this is just a general thing for anything that anybody sends in for repair here on the channel. I don't charge anything for diagnostics or trying to repair it if it doesn't work. If we can't get it working, we charge absolutely nothing. The only thing you need to pay for is the return shipping back to you. Yeah, big breath sound there when that screw broke. Jeez. At least it should be pretty easy for us to extract here. We won't have to replace the whole stud like we did last time when removing the screw it broke. Because of how over-tightened they were. But you guys will get to see it here. And I'm sure it'll help somebody else out there. It's in a crappy spot too, right next to these two tall capacitors. Boy, we messed that one up, didn't we? All right, let me grab some pliers. Alright, this is Extreme Screw Extracting with your host, Nick. This is gonna be fun. I'm almost debating just tearing the stud out and replacing it instead of trying to extract this with the vice grips here. Just out of fear that I'll break these caps off right next to it. Oh, you know what? That actually looks pretty loose. As is, we may be able to... Yeah, you see that? It's coming out. We just need some needle nose, or better yet, just some tweezers here. Little baby steps. Almost got it. At least this happened while we were tightening the screw, and not while we were loosening a screw. This happened to us recently while we were trying to remove a screw, and from the factory it was just glued in there so tight that the head of the screw broke off just like it did here, and it was pretty well stuck in the stud, so we ended up having to tear off the old stud out of the board and replace it with a new one. But this, at least, the screw's coming out pretty easily, so we won't have to go through all that. Can we get it with our fingers now? Oh. Got him. Okay, lesson learned. Don't use the electric screwdriver to tighten any of the screws in here. Totally fine to use it for loosening. Yeesh. Alright, where were we? Let's get that amplifier put back in. And we'll go full manual for reassembly here. Well, I mean, that thing's got some guts. I reading a lot of the Amazon reviews on these electric screwdrivers, I wasn't thinking it was going to have the power to do that. But prove me wrong. It sure did. And we've got plenty of those screws for us to replace it with, so that's no sweat. Maybe the smaller one for assembly. Good point. Good point. I'm willing to take that risk again to see here if this one is any better. Oh, I need to grab that magnetizer from my toolkit. Let's see, is my bit good enough? Yeah. Let's see here. Oh. Doesn't reach in there, but that's okay. I'll find like a super long T6 bit for this thing too. That's pretty good though. Uh-oh. It'll take a little bit to get used to these. Yeah, I bet you if I get a really long T6 bit for this one too, then we'll be rocking. Okay, power supply, take 2. Definitely going to be using the electric screwdrivers for putting in the subwoofer screws and the screws for the top basket, because those two beat up my hands the most. The rest of these get the manual touch. Let's see here. Actually, if we put this bit back in, we can probably... Perfect. Because I don't need these too tight. You want them snug, so they create a good seal with that gasket that's built into it. Very nice. Very nice. I love it. Subwoofer gasket. Mind the part of the gasket here that's got the little notch cut out of it. That lines up with your ribbon cable up there. It's not imperative, but if you want to be perfect with your reassembly, that's how it lines up there. And that's why they put that there too, of course. How did that do? Oh, very nice. That's about exactly where I would put it. Yep. Nice and consistent. Now these screws are where this is really going to come in handy, because these ones will knock you out. Go ahead and make sure one of them is in. That way everything is lined up, and then we can use this. Oh boy. Am I on any other social media besides YouTube? Kind of. If you go to my website, at the very top of the HomePod repair website, I've got a couple of links to my various social medias. If you also just go to track44.moe, I think I've got like my Instagrams up there, but... Oh boy. Feisty. Let's try this one. I think the battery might be dying in this. I used it a little bit before our stream here. And I wonder if it'll let you use it while it's charging. Oh, bollocks. Alright, well, we'll let that charge, and we'll try this again in a bit. Let's go ahead and just use this to tighten all these down most of the way. Do all the hard work for us, and then we'll touch them up with our mechanical screwdriver. Alright. That made quick work of that. Now, did it make them too tight? Yeah, a little tighter than I'd like. Excuse me. Okay, let's stick that ribbon cable back to the top of our basket. Pull that up. Redress our screws here. Get our logic board put in. The upper frame. Let's snug up that mesh. We also want the cat appearing on your live streams from now on. The cats are very shy to my room, just because my room tends to be pretty noisy. But we'll try to get them on here. stock ringtone.mp3. Make sure that power connector is nice and lined up down there. If it's not, then you can just wiggle it around until it snaps into place. Get our display connected. Alright, time for the final piece. Let's get our top stuck down. We're just going to reuse the adhesive here, and we're going to revitalize it a little bit with just a little bit of heat. Being careful not to overheat any of this plastic or focus on any single spot. I like to hold the top cover when we're reheating it so I know if it's getting too hot. If it's too hot for me to hold or too hot for my hands, then it's probably fast approaching too hot for the plastic part itself. And then we'll line those up as best as we can, starting with one button and then lowering it, lining up with the other. We'll come from the top and make sure that looks nice and centered. And then we can push it down. All right. Looks nice and even. Let's go ahead and plug it in. Drum roll, please. All right. Didn't forget anything putting it back together. We'll just double check our behavior here as soon as it powers on. Excuse me. Okay.
I'm having trouble connecting to the internet. For
Excellent.
more info,
So no severe popping when we wake it up now. That's excellent. And our volume buttons here light up nice and evenly. So we've got the top cover on nice and centered. No obstructions. And that means that Sam's HomePod here seems to be all ready to go. So let's set that to the side. And we will move on to Boisy's HomePod. And theirs has got no power. After Boisy's, we'll move on to Edward's. also has no power. There we go. So here it is. HomePod number 2. They say it's got no power, so what we're going to do is we're going to plug this into power and double check our symptoms. Yes, indeed. No power, no response, no nothing. And if we look at the kilowatt meter here, it's telling us that it's pulling about 4 watts of power from the wall. So based on that, we can take an educated guess that most likely our issue is coming from a shorted Schottky barrier diode on the amplifier. It's that same little black diode that we replaced on the last HomePod from Sam that we just fixed for death farts in order to prevent this very issue from occurring. So let's go ahead and crack this open and see if our guess is correct and if we can get it powering on again. So same thing as always, we're not using this to pry this cover off, we're just using it to cut through the adhesive, and after you do go around it enough times it'll just pop right off for you. That'll avoid scratching and cracking that. And then we're going to remove our screws for the display. Wedge our metal tool under there so we can stick the plastic one underneath and then use that to pry our display off. Oh, that came off beautifully. All that adhesive stuck to the frame perfectly. And here's another one where there's like a dent under the display right here. And you guys saw it here. There's no, we didn't get that far. We can't even reach that far with our tool. So how are these displays getting dented that far deep? There's nothing for it to hit up on. So they must just be putting these dented ass displays in from the factory, which is kind of disappointing, but I mean, if it doesn't really affect anything, really, what's the harm? You're never going to see it either. That frame is out, then we can get our logic board out. Just like that. Alright, let's expose those screws for the basket. Attach this ribbon cable here before we forget. Very nice. We'll get these screws out. Oh, yeah. Saving my hands. This is wonderful. Thank you, Jim. Time for the pry. Oh yeah. Oh yeah. Easy peasy. Coming up like a champ. Hey, Boisy, welcome to the chat. Glad you could make it. Yes, victory. Oh yeah, all the no power repairs usually end up going pretty smooth. Even if it's not the most common failure, we usually end up finding where it is and getting it powering on again. I don't think we've come across a no power HomePod we haven't been able to fix yet. Not to brag, but I think we've gotten pretty good at this. Subwoofer voice coil looks good in there. Feels nice and smooth. Smells fresh and happy. So that is a good subwoofer. Out you go. Come on. Nice. Let's get this power supply out. Power supply is out. Last screw. And that amp should be free. Okay, let's get up close and we'll do a quick diagnosis on this amplifier. Confirm the source of our no power issues. I can see it already. We've got a date code on that diode of 1748K, and it looks pretty roasty. Let's go ahead and double check with our multimeter's diode or continuity test mode. It should beep at us if it detects a short or continuity here. Yep, this diode is toast. Speak of the devil. What are you doing? Yeah? Is that all you have to say? Checking out the boxes? Yeah. Yeah, I know. Alright, we gotta go back to fixing Kitty. Let's get this diode replaced with a new one. We'll see if this board powers on. There we go. Old diode be gone. Let's stick that into the temporary dead pile on here. Grab a new diode. We're gonna prep that with some flux and solder. Very nice. A little bit of flux on our board here. We're going to line our diode up. It doesn't need to be perfect because when that solder melts, it's going to pretty much carry that diode onto where it needs to go. But we just want it relatively lined up. Make sure there aren't any pads touching anything that shouldn't, and the flow of solder will do all the hard work for us. Just like that. We'll give it a few taps. Make sure everything is happy and lined up. We've got a tiny little ball of solder just hanging out there that got squeezed out, so we'll just pick that off. Get this off our mat too. And there you go. Look at those beautiful joints. Those aren't going anywhere anytime soon. So that should allow our HomePod here to power on. Let's plug it all together for a test. We'll connect our logic cable here. We do need logic. And that board for our logic. Our subwoofer for that logic. Power for the logic. And while we're testing it, let's go ahead and connect our multimeter to the subwoofer here. So if it's got any DC offset issues creeping up, we can see that as well. Without further ado, drum roll please. Very nice. Okay. So it's booted up. Let's go ahead and check that it's got good sound and we don't have any DC offset issues here. We've got a little offset. Not a whole lot though. That is far below the 50 millivolts that we consider needing repairs here, and it's not growing that fast either. So I'm willing to think that this one is all good, so long as it doesn't pop very loud when we unplug it here. No, that's great. So let's go ahead and throw this one back together. If my judgment is incorrect and we send it back to them and they start experiencing those death farts, I'll be more than happy to get it shipped back here and we'll replace those filtering capacitors for them. But from what I can tell, they still seem to be doing their job well enough. So we're going to roll with them. There we go. We'll put the 14 screws in for the amplifier. You. Get you guys nice and close. Cameron asked, is there a way to find out which values caps have? Yes, there's a few ways you can do it. Before I got my hands on this multimeter here, this one has a capacitor test mode, so I can actually measure the value of capacitors. But that's assuming the capacitors that you're measuring are actually still good. How we found out the value of the filtering capacitors that cause the DC offset issues with like death farts, we found out the correct value of those by looking up the specification sheet of the audio amplifier chip on the board. It's that PAL Raudio IR43 something something, but basically we looked up the schematics for the amp chip, And the manufacturer of this amp chip so graciously also provides a schematic for their evaluation board. So let me back up for a second here and just explain real fast. So this is the chip that's responsible for amplifying the audio signal for your subwoofer specifically. And when we were still trying to figure out where the death farts were coming from, we looked up the schematics for this amplifier chip. And the manufacturer of this specific chip also sells what's called an evaluation board or an evaluation kit. And those are basically just rudimentary pre-built PCBs that the manufacturers put their products on in order for potential customers to buy and evaluate the performance of that product before they integrate it into their own circuits. So the manufacturer of this chip not only provided schematics for the chip itself, but for also that evaluation board. And based on the schematics of the evaluation board, we were actually able to see quite a lot of similarities between the design of the circuit here on the Apple HomePod amplifier and the evaluation amp that this chip came in. That's where we saw that they were using 16 microfarad capacitors here for the DC filtering. So that's how we were able to sort of guess some of these parts all over here. And then once I got my hands on this multimeter has a specific capacitor test mode, so I was able to confirm that they were in fact using 16 microfarad capacitors in here. So a lot of multimeters will give you the basic capacitance test mode here, and it's denoted by the microfarad symbol right here. And obviously that's only going to give you the capacitance of that component. It's not going to give you anything like the voltage rating, its tolerance, its temperature rating, extra sometimes important details. Those extra details for these filtering capacitors we found by, again, looking at the evaluation board's schematics. So from there we were able to determine that they were temperature rated X7R, 10% tolerance, 16 volt capacitors, 10 microfarad, not 16 microfarad. So you can usually measure the capacitance with a simple meter, but finding the additional values, I'm not sure if there's test equipment designed to do that for you, but you'd usually end up needing to look up the schematics of something that either uses the same component and shares the same design, if not the product itself that you're trying to repair. Oh yeah, I replied to your email about that. A handful of other people have just grabbed any random 0.1 microfarad capacitor from like their parts kit or just another board that they had sitting around. It didn't seem like people needed to use necessarily super high rated capacitors for that one that you knocked off. So I would just try to find any 0.1 microfarad capacitor and just see if reinstalling it allows it to work. Based on what other people have been doing when they lost theirs, it does not seem that the other specs of that capacitor are super critical. But that is a 0.1 microfarad capacitor. I think it is size 0402. It's a super tiny one. Get that gasket for the ribbon cable put in here. We do not want to forget that. Otherwise you could end up with what sounds like crackling bass or just straight up dirty bass. I don't have an SMD size chart handy, so I couldn't tell you if it's 0201. I do have my calipers on me, so if we want, let's see if we can measure. It's about 1 millimeter in length. So I think it's half a millimeter wide and 1 millimeter long. So like if you search on Google for an SMD size chart, you should be able to find something that matches that closely. And then our top basket. Get that stuck on there. And then we can use the turbo driver for starting these. And then we will manually tighten them just to make sure that they aren't over tightened. If you over tighten these screws in particular, you'll end up tweaking on the gaskets underneath, and you can cause issues with the sound sealing properly. So it's important to put these in nice and snug, but not too tight. Oh yeah, quick work with this. Now let's just check those all by hand. Beautiful. Make sure that's nice and stuck on there. You're embarrassed by how dirty this is? Boisy, this is pretty clean, all things considered. I wouldn't be embarrassed by this. There's been far worse on here. This is easily one of the nicer condition white HomePods that we have on here. There's no shame in using your stuff and getting it a little dirty either. Man, you should see the HomePod that I have in my kitchen, covered in grease. Got a little bit of a stringiness going on this drawstring here, so we'll cheat with our tweezers to get that in there. Sometimes these drawstrings can be a bit of a pain to feed in, but if you've got some nice needle nose tweezers, it makes it real easy. And we'll tighten up our mesh. This is my favorite part. Excuse me. Nick, could you please repeat the cap size which you measured? Oh, yeah, so that is a 0.1 microfarad size 0402 capacitor, I believe. It's 1 millimeter long by 0.5 millimeter wide, and it's 0.1 microfarad. The rest of the specs of it are unknown, but people have had generally good luck just replacing it with any other 0.1 microfarad capacitor they've had sitting around. Hey Mars, welcome to the chat. Hope all is well in your world. We've got a bunch of viewers today. Okay, time for the final piece for this HomePod. Let's get our volume buttons lined up with us. And then I'll go ahead and explain really quick how I do this. It comes up every once in a while during the live stream as a question. So what I do to stick the top cover back onto the display here, first of all, you want to make sure that there aren't any obstructions or any bits of adhesive covering your volume buttons underneath the display, like right here. Because what will happen, of course, when we put this down, the light won't shine all the way through, and you'll get a weird, funny looking, unevenly lit volume button whenever they're turned on. So make sure that there's nothing covering your volume buttons from underneath the top plastic. Same thing here, you just want to make sure there isn't any adhesive covering these paths here, or these cutouts for the light to shine through. And then we're going to take our heat gun, and just for a few seconds on each piece, we're going to warm both of these up to get that adhesive nice and soft and sticky again. And then when we go to set this down with both of our parts still warm, we're going to line up our one of our volume buttons. We're just going to set the end of this here into the gap in between the plastic and the mesh, so that it acts as sort of like a hinge for us. And we're going to line up one of our volume buttons to its matching partner underneath. We're going to try to line this up as best as we can like this, and then we're going to angle it kind of like a hinge. We're just going to hinge it down, and we're still looking underneath it like this, so that as we continue to set it down, we're trying to line up our other volume button here as we set it down. And then once we're happy, we can drop it down. We're going to stand back up and look at it from directly above. And we're going to do our last tiny little touches to nudge it to where we think is perfectly center before we push down on it. And that'll stick it nice and well back to the top. And you shouldn't have any issues with it popping off on you, or coming apart if you're shipping it either. This has been the way that we've done it for hundreds of HomePods now, and we have not had any issues doing it this way. So let's go ahead. We're just going to heat this up for a few seconds. Move over here, back to the display, back to the top. One more time. And then set it in, line them up, swivel it on your hinge, and just keep it lined up as best as you can until you can't see it anymore and you set it down. We're going to make sure it's centered from the top, and then we can push it down. Ideally, you still want to be pushing down on it while the parts are still warm, so that way that adhesive is nice and sticky when you're pushing the parts together, and it cools down, adhered together by the time you're done. Just like that. And if we take a look, it's got a nice, beautiful factory flush look to it again. So let's connect this to some power and see if we've got all of our issues resolved. Do our usual sanity checks here. Drum roll, please. Very nice. So while this is booting up, I'm going to grab a Q-tip and some isopropyl alcohol, and I'm going to see if we can't clean up this little bit of yellow spot right here. And this is how you can clean the mesh on your own HomePod as well. If you've got tiny little spots or stains here and there. If you've got a larger stain, then you can take a larger cloth or rag, douse it in isopropyl rubbing alcohol, and use that to gently scrub your mesh clean. If you're too abrasive with it when you go to clean it, then you're going to end up starting to accidentally separate the layers from each other, and they'll kind of look funny and feel a little loose. So just go gentle with your scrubs. Be patient. And if you need to, go through like, go through a couple of Q-tips if you need to. And just keep dousing it in alcohol and giving it light scrubs until you think it's not going to get any cleaner. And sometimes, of course, the stain is deeper than just surface levels, so you can only get it so good. But in most cases, that's going to take care of you. So let's do our usual sanity checks here. Make sure we've got good sound.
I'm having trouble connecting to the...
Very good.
I'm having
And our volume buttons light up nice and evenly. So Boisy's HomePod is all fixed up and ready to go home. Let's set that to the side. Thank you so much for joining and watching Boisy. It's always a pleasure to revive these things on the stream here in front of you folks. So last up, we've got Edward's HomePod here, also with no power. Let's fix up the text on the screen here. Reset our cameras. And let's get their box opened up here. Here we go. Come out, little HomePod. Let's get rid of that power cable there. And here's our HomePod. Oh, so welcome to the stream. I'm not sure how you pronounce your name. I'm going to just say Mr. H, if that's all right. So Mr. H here asked, I didn't see you disconnect or reconnect the original power cord. I'm wondering how that is done. So this is a pretty easy little cable to work with here. We'll go ahead and zoom in. So there is a right way and a wrong way to plug this in, and it's pretty obvious. Granted, there's only two ways to plug this in, the right way and the wrong way. What you do is just simply, you see there's two little pins inside there and two pins in the HomePod. So you're just going to line those up. If it's not going in, you can just keep twisting it around until it just wants to plug in most of the way. And we can see here that is incorrect. So we're going to remove that and just flip it around 180 degrees. Just like that. So we can see now that it's, the plastic on the power cable is more contoured with the HomePod mesh. So that's the correct way. And this is the obviously incorrect way. You're not going to cause any damage doing it this way. It just looks incorrect. So anyways, once you've got it oriented and inserted the right way, all you need to do is take your fingers and push up against the plastic here until, push it into the HomePod until you hear it click. Just like that. And now you can see it's not going anywhere. It's nice and flush with the body of the HomePod. The bottom of the connector isn't jutting out. And then to remove it, it's pretty simple. What I like to do is just wrap it around my hand a few times, have it sat on a desk, hold it down with one hand, and then with the cable wrapped around the other hand and a little bit of slack, you just yank it off. Alternatively, if you want to go slow and easy with it, you can just place one hand here, pull slowly but firmly with the other hand until it pops out. And that's all there is to it. Replacement power cables for these are fairly cheap. I've bought quite a few of them myself off eBay, both from U.S. local sellers and China, or sellers from China. I haven't noticed any difference in the quality depending on anywhere that I order it from, so I think all of the power cables that you can find online are relatively safe to use. Granted, considering the HomePod wasn't necessarily a super popular product per se, I can't imagine there were very many counterfeit, if any counterfeit, power cables made. So far, all the ones that I've bought off eBay have all appeared to be perfectly genuine. So, let's go ahead and connect our own power cable to this. And we've got that plugged into our watt meter here. We're going to double check our symptoms from Edward's HomePod with no power. And sure enough, we've got no response or any lights whatsoever when we plug it in and tap the top. And then if we check our watt meter here, we're pulling about 3 to 4 watts of power from the wall. So based on no response and that specific power draw, we've most likely got the most common no power issue here, caused by the shorted diode on the amplifier, like many others. Let's crack it open and see what's going on inside. And those power cables, they are very robust. You don't need to worry about breaking them if you're worried about breaking them, unplugging it and plugging it in so many times. We've used the same power cable here on our repair live streams for the majority of our repairs here. And they are very durable cables. You're more likely to send your HomePod flying off the table and breaking your HomePod itself than you are damaging the power cable trying to unplug it or plug it in. There we go. Now time to pry the display off. Metal tool to start it. Plastic tool to finish it. Oh, another one that came up almost perfectly. Let's stick that part back down. Good enough. Get this display disconnected. then our frame can come out and our logic board. We can pull that mesh down, uncover our screws for the basket. And then we're going to use our screwdriver to take those out. Oh, one other thing I almost forgot, Chuck. When you were asking about cleaning and replacing the mesh and removing it. Yes, the mesh is removable, and it's actually one of the easiest things to actually do on these. But I've got an upload in my uploads playlist on YouTube on specifically removing and reinstalling your mesh on these. If you haven't noticed, we don't have to actually remove the mesh all the way for most repairs. The only time you need to actually fully remove the mesh is if you actually want to clean or replace the mesh itself. But you can be pretty liberal with the rubbing alcohol. It's not going to ruin anything. There we go. And now it's time for the pry. Pry. And boy, it's putting up a fight. Yeah, that one's really stuck in there. Come apart, little HomePod. Give it up. There we go. Yes. Get that extra adhesive removed. So when we put this back down, it sits nice and flush. And then our subwoofer can come out. Woofer check. Voice coil, good. Actuation, smooth. Smells fresh. Hey Robin, welcome to the stream. Welcome to the chat. Welcome to the world. Yeah, you spotted it. One of the guys that we did, that we fixed their HomePod up for, had sent in not one, but 2 electric screwdrivers. This big chonky boy here, which I've got an extra long T6 bit for, and then this much smaller little tiny guy. And they work wonderfully for taking these things apart. They also work really well for putting some of the screws back in. We go in with our manual tool and make sure that everything's tightened the way that we want, but this gets most of the work done really easy. Yeah, I actually missed it. We tried this out on the first HomePod that we repaired on our stream here a few hours ago, and ended up, oh, well, let's see how well it torques down the screw for the power supply, and it snapped the screw right off. We ended up creating a little more work for ourselves, but we got it fixed up no problem. And a little bit of a learning experience. Yeah, definitely saving my hands. I was starting to get callous and weird spots on my fingers. And sometimes you just don't want to sit there and keep cranking on these screws. This makes it so much easier. All right. What we all came here for, our amplifier board. To be specific, that thing. Looks kind of toasty if you ask me. Let's grab our meter and just double check that that is shorted out and needing replaced. Yes, indeed. Let's get that replaced. Ooh, getting your second one in for repair. Fun. What is the set temperature on your hot air station for removing the diodes and capacitors? I have mine turned up all the way to the maximum temperature of 500 degrees Celsius. I'm using the largest nozzle that it came with. It's about roughly the same size as this diode. And I've got my airflow speed set to about 80%. Oh, looks like we bumped that other cap up there. Let's just fix that up. There we go. Stick that in the dead pile. Grab ourselves a new one. Bonk. Didn't mean to hit you guys there. I need to find like a good camera that I can stick overhead instead of my iPhone here. Something that's got really good optical zoom so you guys can see the components here. Basically about as close as this is as much as I need it really. But something that's got a good enough quality for the overall that can also optically zoom into the actual components. It doesn't need to zoom in too far, but about this far would be nice. So that way I can stop, you know, running two different iPhones for a camera and having to switch between the two scenes. That'd be nice. Any suggestions are very welcome. Preferably ones that don't break the bank. Because I know there's, you know, the Canon and the Sony, like, I think they're like the DSLRs or whatever. But that's going to be a few $1,000s out the door with like lenses and the camera body and all that. That might be what I need to get though. That just might be what I need to save up for. Or maybe we could find one broken on eBay and fix it up. That's how we got our hands on so many HomePods. You just buy broken ones. That's why I like fixing so much. Well, one of the biggest reasons why I like fixing so much is it enables you to gain access to so many things that you otherwise wouldn't have been able to afford. Like a bunch of HomePods. There's no way I would have paid retail for as many as I have now, but for an absolute fraction of the price. Oh yeah. And what's it take? A little diode less than $1 and 30 minutes of my time? Deal. Watch Adam IT. He uses a Logitech Brio 4K webcam. I'll have to look at that. I'll check that out. Look at how crooked that is. Is it gonna fix itself? That's nuts. Fix yourself. Oh, like magic. Did you see that? Did you see me? Alright. That all looks good. Let's switch our cameras back over. Give this board just a few seconds of cool air. And then we will give it a quick test. Okay. Power supply. And I'm fortunate enough that my eyesight is still very good, that I don't need any microscope, or I don't use the iPhone camera zoomed in to see what I'm doing. I just use that so you guys can see what I'm doing. I can see what I'm doing just fine. So something that's not in my way that allows you guys to see. That webcam might do the trick. Especially if he uses it for his board repairs, that might just be what I'm looking for. Yep, I know the subwoofer's a giant short, but we want DC millivolts. So let's power this on. Let's see if it powers on, of course, and if it does, we'll check out its DC offset as well. Drum roll, please. Baba booey. What's it got? What's it got? What's it got? What's it got, stuntman? Oh. Oh. Oh, no, 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 no. No, we don't want that much. That is within the same realm that we saw with Sam's first HomePod on the stream today that we fixed up. If we leave this alone, sure, let's just back up really quick. This HomePod was sent in for no power, right? So if we were an unwitting repair shop that didn't know that you should be checking for DC offset on every HomePod that you've taken apart, regardless of what you've taken it apart and tried to fix it for, no power and death farts from DC offset are two completely different issues. Yet here we see another HomePod that suffered the no power short, and when we got that fixed up, lo and behold, it's got a dangerous amount of DC offset as well. So, the previous owner may not have noticed the significant popping noises, and they may not even have noticed any death farts at the time, but I am positive if we leave this alone at that high of a DC offset, our subwoofer would cook itself, and they would probably experience death farts along the way if all we did was repair the no power issue. So we're going to go ahead and remove all of our test parts from this, and we're going to replace those filtering capacitors so that we get this DC offset under control. That is a good question. Robin asked a great question. So they said, what places do you probe for DC offset? So what you normally would do, if you don't have a special setup like I do myself, is you would... what you can do is you can, you'll need to disassemble it a little bit. You need to get it past the point to where you can take the subwoofer out, but you can leave the power supply and the amplifier in here. But what you want to do is connect your subwoofer to the amplifier, connect your logic board, get it all powered on. You can set the subwoofer to the side on the outside of your HomePod shell. There's enough cable length for you to do that. And where you want to connect your multimeter is, if you look at the side of the subwoofer here, let me go ahead and grab a different one so you can see a little better. But here is your subwoofer, and it doesn't matter which probe from your multimeter you put onto what point. You can put positive on negative and negative on positive, or you can match them up. It doesn't matter. What matters is how much voltage away from zero you are. That's why it's called DC offset. You want your DC offset to be zero. That is a perfect world. But unfortunately, the world isn't perfect, and electronic components are far from it. So every audio amplifier is going to inherently have a little bit of DC offset, or in other words, a little bit of DC voltage away from zero flat. You want 0 volts of DC because then your subwoofer is resting in its perfect neutral position. If you've got positive or negative DC voltage, it's going to hold the subwoofer, in a different position, and it's going to produce a constant load on the woofer, on your amplifier, and cause all sorts of issues. all that said, you simply just need to put your positive and negative probes on each of the contacts on your subwoofer here, and that will give you your DC offset reading. Make sure that your amplifier's on and not in standby mode. You don't want to, take measurements while you're playing music, but you don't want the HomePod in its low power state either. So, wake it up, connect your probes to the side of the speaker here, and that'll give you your DC offset measurement. What I've done here that's a little special is I've actually soldered a couple of alligator clips to some wires onto my subwoofer here. So instead of me having to sit here with my probes and hold it to the woofer every time we've done our repairs and we want to check for DC voltage, we can just connect our probes to our alligator clips here. And that'll give us our reading. So in that amount of time we've been talking, we've already grown up to 800 millivolts of DC offset. So let's go ahead and let's replace those filtering capacitors, see if we can improve that DC offset, and then we should be ready to reassemble. Also, if you have any questions about any of the repairs that we do here on the channel, or about any, HomePod repairs in general, I always suggest checking my website. It's up at the top left there, nixfix.com. I've got a section for common issues, and each common issue will have steps and any known ways to diagnose that specific issue and repair it. And if you need any parts for that repair, I give you part numbers for everything that we do know. Specifications for the part at least, that you can find a suitable replacement on your own. Okay. So same as with Sam's HomePod at the beginning of our live stream here today, we're going to replace those 4 filtering capacitors. And that should get rid of our DC offset there, or at least bring it into spec again. There we go, easy peasy. Let's grab our new capacitors. We'll put some flux on the board and tin those pads with some low melt solder. Default ringtone.mp3. won't do. A little more flux, and we'll throw those new caps on there. Beautiful. Do you know how big the voice coil is for the 4-inch woofer? I do not, but we can find out together with our handy dandy Harbor Freight digital caliper. And let's grab a voice coil from our parts bin here, or should I say the graveyard. And if you're curious about the diameter here of the voice coil, that is going to be an inner diameter of about 32 millimeters and an outer diameter of about 34 millimeters. In inches, that's going to be an outer diameter of about 1.3 inches and an inner diameter of about 1.27 inches. Hope that's what you were looking for. If not, just let me know what it is exactly you wanted me to measure and I can check that for you. Okay, so let's just double check the quality of our joints here. We like high quality joints. Only the highest quality. Oh yeah. They're not perfectly centered. Yeah, that bottom one could use a little scooting down. So let's just do a little more flex. We were gonna do this anyways. Also, I was looking at your teardown. It looks like the tweeters are inverted dome aluminum. Let me check. I've got a few that are broken that we can take a look at real fast from the inside. It gives this board a chance to thoroughly cool down. Where did I put that thing? Yes. So I've got two examples here for you, Mr. Robert. So here's one that I've taken the whole shell out of. And then if we pop this off, just like that, get the insides of that. And then you can kind of see through that other side. So that's what the speaker itself looks like. And then here's what they look like in the actual shell. can see in there. These tweeters were already destroyed when I got this HomePod, so there's no harm here. They were destined for the trash. So at least they're giving a little more usefulness out of their life before their ultimate fate. But I hope this helps you identify the actual type of speaker here. I've heard the term BMR speaker thrown around a lot when people have been talking about the tweeter speakers in the HomePods. They've got a surprisingly large frequency response. I think it's somewhere around 200 to 400 hertz up to like 20 or 25,000 hertz, and the subwoofer handles everything from that 200 to 400 range down. But these have a surprisingly wide range of frequency response, or what have you, whatever you call it. Okay. Double checking the joints here. My camera won't focus. Come on, hocus focus. Alright, well that decided to stop focusing, but that is okay, because we've got everything we needed to taken care of here. Let's throw this together and see if we've got our DC offset corrected. Yeah, so BMR speakers are essentially, like, from my understanding, they're like a mid-range speaker with a tweeter embedded into the actual mid-range speaker itself. So they're able to produce a wider range of sound than your average single speaker can. It's like I always say on this channel, and why I love these HomePods so much. There's just so much crazy hardware packed into these things, as far as, you know, the number of speakers, the performance of each speaker, and the types of speakers that they used. It's in my opinion, completely unmatched against anything else, even to this day, currently available on the market. Sure, you've got other speakers out there that may be louder, or maybe produce a, you know, potentially better sound, but it's either super directional or it's wildly more expensive. I have still not come across anything, again, in my opinion, that has come close to exactly what the HomePods do, and that is provide a full, amazing sounding, omnidirectional, sound with excellent room correction and an excellent frequency response. Like, it blows me away every time I listen to anything on these things, and the bass hits and the, you can feel the different layers of the track in your music. It's nothing's come close. And I've got, I kind of know my way around speakers. I've got a 7.1 home theater set up with a Yamaha Avantage amplifier, and KEF speakers and Klipsch subwoofer. I've actually got two subwoofers. One's a Klipsch and one of them is Bic. But I think I know a thing or two about audio, and I wouldn't consider myself quite an audiophile, but I do feel like I've got a bit of a discerning ear for what sounds good and what doesn't. And I'm just blown away by HomePods. For their size and their price, what they can do, nothing comes close. I really hope they come out with a new version of it. And that would be great because, with their new self-service repair program, that means that we would have parts to actually fix our own speakers. It'll be interesting to see if they do anything for potential software issues, like allowing you to connect it to a computer and restore it, what kind of parts they'll make available, and if this new version is going to be similar at all to the original HomePod, potentially what parts we may be able to swap between the old and new generations. That's what I'm hopeful for. So do we have our DC offset fixed? Yes, we do. We've got it well under control. We are around, it's probably going to settle at around 1 or 2 millivolts as it continues to cool down a little bit here. But as long as it's below 50 millivolts, I'm happy with that. And as long as it's below a couple hundred millivolts, we should never experience any death farts or severe popping. So this HomePod is ready to go back together. What do I think about the HomePod Mini? Again, for the price, I'm hard-pressed to find something that performs as well as even the minis. I've got one mini on my office desk at the office, and because I don't want to waste a full-sized HomePod's potential for the 1 day a week, if that I'm there to actually use it. But the mini on my office desk in an open cubicle in a giant open office still sounds incredibly full and dynamic, and it's not like I can have it set to a really low volume. It's loud enough that I can still pretty much thoroughly enjoy like the listening experience without it actually bothering other people. And again, for the price, like new $100, that's kind of a lot, but it's got some decent freaking sound performance. It's nowhere near the OG, right? Like you're talking about one $100 speaker with literally one single speaker inside of it versus a fuller sized HomePod with a dedicated subwoofer and 7 tweeters or mid-range speakers. So that in mind, the Mini is just absolutely, in my opinion, again, fantastic speaker. For what they made it for and for its intended use cases, they nailed it. And then, look at the used market. You can get these things for $20 to $40 a piece. If you look and you're patient. I got 5 of mine for, like $10 to $20 a piece. They were all broken, wouldn't power on. And I just plugged them into my Mac. And they allowed me to restore them, and they work just fine. So they are great little speakers. Not anything that I would use for like an actual serious sit-down listening session. But for the places where you like don't really need that huge full sound, you just need something that still sounds really good, but you don't need to rock the house. Or just a decent little speaker that you don't want to worry too much about breaking or losing or getting stolen or, just not using as much. Excellent little speakers. I wouldn't go and fill my room with them. I would rather fill my room with OG HomePods. But like for the kids, for the office, for the garage even, like you don't want to worry about someone breaking in and stealing your $300+ collectible Apple speaker. Who you lose a mini or two, whoop-de-doo. You can, it's not nearly as big of a deal as the big ones. And again, for its size, I'm thoroughly impressed by the sound. I haven't heard many speakers for that price, at that sound, or at that size, sound that good. That's another great use case, like sticking them around like a waiting lobby or like an office lounge, just to have like background music going on. Get a couple of them, set them around the room. No wires to fuss with except for power. Yeah, a lot of people complain about not being able to plug an aux cable into it. Which is a valid, it's a valid complaint. Would be nice to see that in the newer versions. But I wouldn't hold my breath. And for those people that just absolutely need to have the ability to pipe any audio into their HomePods, if you get an Apple TV, you can connect. You can enable like the eARC return thing. I can't remember the specifics about this, but basically you can set your Apple TV, whatever's playing on your TV, you can have that audio channel return to the Apple TV, and then AirPlay that to your HomePods. So I've seen people on the HomePod subreddit use this for playing their PlayStation or Xbox game console audio on their HomePods. I've seen people hook up. If I keep talking, I'm gonna mess up this. So let me get the power supply in. Talking and working on repairs at the same time can be very dangerous. You end up forgetting steps or screws. TBH, I never use aux anymore. Well, who do we have to blame for that, huh? Apple. Taking the headphone jack out of the iPhone, creating an unnecessary industry trend. You can tell I was one of the people salty about that. Like, I like my $1,000 smartphone to be more of a Swiss Army knife, and that includes having the ports that I want to do something at weird, just weird edge use cases. It's like that one time you need something and the tool that you have could have done it, but it just didn't have everything you needed. It was such a simple thing, such a staple in smartphones, just having an auxiliary jack. And then people had to go out there and make Apple look real bad by hacking auxiliary ports into their iPhones, proving that it was actually possible. I get it, man. You want people to move on to Bluetooth and buy their wireless earbuds and all that. But I feel like people were going to do that anyways. You didn't need to force them onto it. That's just my crazy talking though. I've had one little hiccup where the woofer on one of my HomePods was distorting, but a factory reset fixed that issue. Yeah, I've seen that on mine too. I can't tell if it's overheating. I experienced that on one of my own HomePods literally this morning, and I wanted to do a deeper dive and see if there was anything actually failing, or if it was in fact just a software issue or overheating. And from what I can tell, the logic board got, it'll start to run pretty hot, but it didn't seem like it was in any kind of unsafe territory. It just seemed to me like it was having issues struggling with the software, because when I would try to interact with Siri, it was really laggy and very unresponsive. And doing a power cycle cleared it right up, and I couldn't reproduce the issue. So it's one of those things that I have to chalk up to software issues. I would rather there be an easy hardware issue that you can just repair and be done with it. But we are at the mercy of Apple fixing it in software. if Apple releases like a new HomePod, I want to be the first channel to take one apart. I'll go broke doing it, but I'll do it. I'll buy a brand new one at full retail price and immediately open it up on stream. See what makes it tick. See what potential faults it may have. Yeah, I think that's likely. It runs for so long. Its cache builds up. It slows down. Gets confused. And then it starts running out of CPU cycles to play the audio at the intended quality, so it has to keep dropping it until it can keep up. And that results in a really nasty sounding just sounds really bad. Oh, this is great. Jim, thank you again for this. Woo! That thing does have a lot of torque, though. You gotta be careful with it. Because it will twist it right out of your hand if it doesn't twist what you're working on right out of the vest. Man, that just makes the job so much easier. I'll take the extra minute to have to go over these screws twice if it means most of the hard work is done with the electric one, because that just saves my hands so much work, so much callousness. Robert asked the question, what causes the death fart? I've explained it quite a few times on stream, but I'll go ahead and give you the quick rundown again for you. So death farts, just so we're all on the same page, are when your HomePod emits a loud, it sounds like almost like a bass drop. It goes pew. And then shortly after, it'll do a hard reset. You'll see it rebooting. So that's what a death fart is. What causes the death farts are the filtering capacitors on the back side of your amplifier, right here. Their job is to filter the unwanted DC voltage from your analog AC audio, amplifier circuit here. So what happens is these capacitors eventually stop filtering DC voltage from the amplifier. That gets sent to the subwoofer, and when that DC offset grows past around 2 to 3 volts, the amplifier will notice that and it'll force a restart, which is where you hear that death fart sound play, and then the restart behavior followed by that. That death fart sound is the amplifier basically saying, uh-oh, and forcing a restart. So it happens when the filtering capacitors fail to filter too much DC voltage, and it results in the amplifier forcing a restart in an attempt to, cool off, try to reset the capacitors, bring the DC voltage back down to normal. But if the filtering capacitors are bad enough, then it's just going to grow back to the 2 to 3 volts again, and it's going to keep farting and restarting over and over until something breaks. So death farts are caused by too much DC voltage being allowed through the amplifier before it is sent to the subwoofer. I've actually got a section on my website. If you go to my website, nixfix.com, go to the common issues, and then look for the DC offset common issue. And I've got just a little more technical explanation and a little more in-depth steps on diagnosing and repairing the death farts. And something that you should know is, of course, that the analog audio that's sent to the subwoofer, as is any analog audio that gets sent to any analog speaker for this matter, is AC. It's alternating current. It's not DC, not direct current. So you only want AC going into your speaker. If you have any DC voltage going into your speaker, that's bad. Your audio shouldn't have DC voltage in it. And there are filtering capacitors on the amp that are supposed to remove that. And they go bad, and they allow too much of that DC through to be amplified. And when the amp sees so much DC voltage being amplified and sent to the speaker, it death farts and restarts. Probably in a vain attempt to try and save itself. But like I said, if it's death farting and restarting all the time, it's not going to help. It's just going to delay the inevitable. Yes, death farts can destroy the subwoofer. And there's two ways that it can do that. Literally, the death fart itself, because of how loud it is, it's basically playing a bass drop sound at full volume. And when you see the actual subwoofer doing it, it's quite concerning. Because I generally don't see the subwoofer move as much as it does during a death fart as it would playing any normal music, even at max volume. So the death fart itself can physically damage the subwoofer speaker if it does it enough times that way. And then the root cause of the death farts, like I was saying, that excess DC voltage that's causing the death farts, that's more likely what's going to cook your subwoofer. Because essentially what it's doing is it's taking a constant DC voltage and applying that to the subwoofer. And you can see when I apply DC voltage to the subwoofer, it moves the subwoofer speaker. And when it does that, it's basically putting a constant load onto your speaker, which is going to overheat the speaker. It's going to make the amp work harder than it needs to. It's going to accelerate wear and tear and damage on all of your parts. So, yes, there's a few ways that death farts can destroy your subwoofer. If your HomePod is actively death farting, I would strongly recommend unplugging it from power until you can get it fixed, before it kills your subwoofer. Because once it kills your woofer, man, there's nothing you can really do to economically save that subwoofer speaker. Once it's gone, and it needs to be replaced. And then, on top of the actual repair for the issue, which is replacing those filtering capacitors that allowed it to happen. So if your HomePod's got flatulence, don't ignore it. Disconnect it and call today. apparently you can buy the knockoff, or yes, apparently you can buy the subwoofer off AliExpress. I genuinely believe that they are original replacement subwoofers. Simply because of the attention to detail that was put into the speaker basket, the specific cutouts and placement of the holes, and every little detail in general about these AliExpress replacement subwoofers that I've seen, at least from the photos, they look 100% genuine. And they, more likely than not, probably somehow got them from the factory that originally manufactured these subwoofer speakers. That said, I'd like to buy a few and get my hands on them just to see for sure. Hey Robin, thanks for dropping by. Have a good night. I think the gentleman on YouTube that did the recent HomePod repair in German, I think he ordered his replacement speakers off AliExpress. I'm not sure. I'd be really curious as to where he got them if it wasn't the AliExpress listing. I would be impressed if somebody went that far as to make a knockoff replica of the HomePod subwoofer. That is a very, very niche product to be producing knockoffs of. Not impossible, but I think it would be unlikely. Alright, final touch for the final pod. Alright, let's plug this in and see what it's got. All right.
I'm having trouble connecting to the internet.
We've got full sound.
I'm having trouble.
And our volume buttons light up nice and evenly. So, we're going to do this with all the other ones, of course, before we send them back. Let's go ahead and wipe that top off so it looks nice and fresh. And there we have it. We've got all three HomePods sent in to us today, all fixed up. First one from Sam with death farts, which was caused by the filtering capacitors on the back of the amplifier going bad, allowing too much DC through the amplifier and into the subwoofer. So we replaced their filtering capacitors and gave them a new Schottky barrier diode for good measure. And then we moved on to Boisy's HomePod with no power, and it ended up just being a shorted Schottky barrier diode on the amplifier. So we got that replaced, and it didn't have any DC offset. And then we wrapped up today with Edward's HomePod here that seemingly just had no power at first, but once we got it powered on, of course, it had a growing case of DC offset, which, if it was ignored, would certainly start causing death farts and bass issues for Edward here if we didn't get that fixed up. So we got it all taken care of for him. If any of you guys have any questions about any HomePod repairs, feel free to leave a comment below. I suggest first you check out my website, nixfix.com, and head over to the common issues section, where I've got all of the common issues that we've fixed here on the channel, ways to diagnose and repair it, and any part numbers if we've found any that you can use for those repairs. I've also got my contact info up there on my website if you'd rather mail your HomePod in to be repaired here on the channel. Hope you all enjoyed watching, and I'll catch you in the next one. Goodbye!